Hey guys, this is Coach Brian. Quickly going over the 2.4 notes for geometric proof. I'm just going to jump right in. We've been kind of building up through through all of Unit 2, talking about different ways of logically thinking, talking about different statements, how to manipulate those statements, make things like the converse, the inverse, the contrapositive, etc. And now we're getting into where we're using all that logical thinking to prove mathematical things that we're talking about in class. And so the first thing we're talking about is a theorem, which is something that we have talked about previously, but a theorem is a statement that has been proven true. It's been proven true. And the reason that's important is because we're going to use theorems to build arguments. You can use it in later proofs, okay? Use it in later proofs. And so just jumping right in, we're looking at these situations where we are given some information. We're going to use that information to write a statement, and then we're going to justify that statement with some reasoning. And so in our first example, it says that point E, is the midpoint of segment AC. So we got A to C, and E is the midpoint. So that automatically tells you that each of these segments is half and half, and they're equal to each other, okay? So just knowing that, an example of a statement that we could make, we could say, knowing that E is the midpoint of AC, we could say that segment AE is congruent to segment EC, segment E to C. And how do we know that? And what I mean by that is, how are you able to prove it? What's your reasoning for it? Okay, what's your proof or your reason for that? And for us, we would be using what we call the midpoint definition, or the definition of midpoint. And we know what a midpoint is just from our earlier studies, even this year. It's a point that is right in the center of a line or segment. And based off that definition, E is the midpoint from A to C. So we know that each segment, A to E, E to C, is equal. All right, moving on now to example 2. It says that AC, segment AC, bisects segment PQ at point O. Bisect is a very important word, just like midpoint. It is an angle divided into two equal angles, or a segment divided into two equal segments. All right, so a bisector. The important thing to remember there is two. Let me write this in a different spot so that I don't block my statement. Important thing to remember there is two equal cuts, if you will. Two equal cuts. Bisect, two cut. All right, so two equal cuts. So it's bisecting PQ. That means that this is half and this is half, all right? And we don't know that AC is being bisected from what's given. We only know that P to Q is bisected. So we can't make really any statements about AC. But since we know that this is bisected, we could say that O is the midpoint of segment PQ. And then when we think, why do we know that? Well, it is the definition of a segment bisector. Again, from Unit 1 notes, we defined segment bisectors as a line or array that divides a segment right down the middle into two equal parts. So that theorem, that definition is our proof of the statement we're making right now. For example 3, example 4, 5, and 6, example 3, 4, 5, and 6, you'll see these different tables, all right? And when you're filling in these tables, it's pretty much breaking down the given all the way down to what they're asking us to prove. If you notice the prove right here and the last thing in the table, those match. Excuse me. Those match. So pretty much what we're trying to do is take a starting piece of information and reason our way down to what they ask us to prove. And so when we start off, we have a given, just one. Sometimes you get more than one. And we have one thing that we need to prove. And so our given is that B is the midpoint of AC, segment AC. And actually, all right, I misspoke. I said there was one given, but we actually have two pieces of information here. We also know that A to B is equal to E to F. So what I like to do is go ahead and, if I have an image, I want to go ahead and mark that image up so that I can keep track of all the information presented to me in the problem. So B is the midpoint. That lets me know immediately that this is half and this is half. But that second piece of information is also really, really important. A to B, this distance right here, that segment A to B, is equal to E to F, okay? That's equal to that segment. And so as we're trying to reason our way through this, we have some possible reasons down here. Sometimes it's given. That means they just told us that this is true, and we're going to accept it. We have the definition of midpoint, the transitive property of congruence, always a bell when we're recording every single time, definition of congruence, and the segment addition postulate. So if you're not sure what these mean, it's always a good time to look them up and refresh your memory on them. It might be something that you've learned before. It might be something totally brand new to you. But it's a good opportunity as you go through these. Like I said, you've got examples 3, 4, 5, and 6, and then you've even got some in your practice, and they all have different reasoning. And so it's a good time to read over those, look them up, maybe write their definition out to the side, and as you practice them more and more, you will become more familiar with them. For this one in particular, B being the midpoint of AC is given to us. It is directly stated right here. B is the midpoint of AC. So it is given to us. Now, AB equaling B to C isn't given to us, but we know it because of the definition of midpoint. We know that since B is the midpoint of AC, that it divides that segment into two congruent parts. Then AB being equal to EF, well, that's right here, also given to us. And then lastly, if A to B equals BC and A to B also equals E to F, is it reasonable to say that B to C also equals E to F? And it is reasonable to say that because through our last, three statements right here, all of these are equal. And that falls under what we call the transitive property of congruence right there, okay? So if you're not sure what that means, like I said, you can write a little definition out to the side. A to B equals B to C. Guess what? B to C equals E to F. Those two also equal each other, okay? Transitive property of congruence. For more help with proofs, I would also click this link. This is about a 2-minute video, even less, of an example proof being walked through, just like the one that we just walked through. Now, for examples 4, 5, and 6, I want you to walk through these yourself, all right? I want you to try to walk through these either with the group that you're sitting with, maybe try them on your own, maybe walk through them with the teacher, but for sure, the things that I want you to get are the names of these particular theories. And so our first one, you'll see it right here. Our first one, excuse me, is called the linear pair theorem. Linear pair theorem. And this is what it states right here. Sorry, I cannot write. This is what it states. If two angles form a linear pair, then together they are 180 degrees, which is supplementary. Okay, that's the first one I want you to get. Second is going to be under example 5. And the reason these are like tied to the examples is because they demonstrate what we're talking about. So example 4 demonstrates the linear pair theorem. Example 5 demonstrates the one we're about to talk about, which is the right angle congruent. See if I can fit this on the blank. I cannot. Theorem. Right angle congruence theorem. And that one's pretty simple. It states that all right angles, right meaning 90 degrees, all right angles are congruent. And example 5 proves that. And then lastly, we have example 6 on our notes. Example 6 is, trying to mix up my colors a little bit. Example 6 is proving the congruent, definitely not going to fit this one, congruent supplements theorem. And that says if two angles are supplementary to the same angle, then they are congruent, and you will see that demonstrated through example 6. All right. Good luck as you do examples 4, 5, and 6. Reach out to me or your teacher if you need extra help. Really try to look up these reasons and see what they are, and see if you can use them to justify and prove each step of your reasoning along the way. See y'all next time.